Today we'll be doing the integral from 0 to pi over 2 of x over 1 plus cosine x dx. And to start off, we will call the double angle formula for cosine. And it's going to be that the cosine of 2u equals 2 cosine squared u minus 1. And if we substitute in u equals x over 2, we have cosine of x equals 2 cosine squared of x over 2 minus 1. And then adding 1 on both sides, we have that 2 cosine squared of x over 2 is equal to 1 plus the cosine of x. So we'll substitute this into our integrand, and we have the following. We have the integral from 0 to pi over 2 of x over 2 cosine squared of x over 2 dx, which is equal to 1/2 the integral from 0 to pi over 2 x times the secant squared of x over 2 dx. And then from here, I'll make a substitution. So I'll let y equal x over 2, which means that 2y equals x, and that 2 dy equals dx. And the bounds of integration will be y sub 1 is equal to 0 over 2, which is equal to 0, and y sub 2 is 1/2 times pi over 2, which is pi over 4. So our new bounds are going to be from 0 to pi over 4. So it's equal to 1/2 integral from 0 to pi over 4 of x, but that's 2y, secant squared of x over 2, but that's a y, and dx is 2 dy. And as you can see, we have some cancellation. Bring the 2 to the front. It is equal to twice the integral from 0 to pi over 4 of y secant squared y dy. And from here, we can use integration by parts. So we'll let u equal y, which means that du equals dy, and we'll let dv equal secant squared y, which means that v equals the integral of secant squared y, which is the tangent of y. So we have twice y times tangent of y from 0 to pi over 4 minus the integral from 0 to pi over 4 of tangent of y dy. So evaluating the limits, we have 2 pi over 4 tangent of pi over 4 minus 0 tangent of 0 minus the integral from 0 to pi over 4 of the tangent of y dy. Tangent of 0 times 0 is 0. 2 pi over 4 times 1 minus the integral from 0 to pi over 4 of the tangent of y dy. And distributing the 2, we have 2 times pi over 4 minus twice the integral from 0 to pi over 4 of the tangent of y dy, which is equal to pi over 2 minus twice the integral from 0 to pi over 4 of the tangent of y dy. And we will recall that the integral of tangent is the natural log of the secant of y. So this is equal to pi over 2 minus twice the natural log of the secant of y from 0 to pi over 4. So this is equal to pi over 2 minus twice the natural log of the secant of pi over 4 minus the secant, it's going to be minus the natural log of secant of 0. So this is equal to pi over 2 minus twice the natural log. The secant of pi over 4, well, the cosine of pi over 4 is the square root of 2 over 2. So the reciprocal of that would be 2 over the square root of 2 minus the natural log, and the secant of 0 is 1. So, and we know that the natural log of 1 is 0. So it's equal to pi over 2 minus twice, and using logarithm rules, we have the natural log of 2 minus the natural log of the square root of 2. So this is equal to pi over 2 minus twice the natural log of 2 minus twice the natural log of the square root of 2. So is equal to pi over 2 minus the natural log of 2 squared, using logarithm rules again, minus the natural log of the square root of 2 squared. So we have pi over 2 minus the natural log of 4 minus the natural log of 2. And then using logarithm rules again, we have pi over 2 minus the natural log of 4 over 2, which is equal to pi over 2 minus the natural log of 2. So therefore, the integral from 0 to pi over 2 of x over 1 plus cosine x dx is equal to pi over 2 minus the natural log of 2. And that is the final result. Thank you very much for watching.